Hello, folks. This is a quick little dive into E. For those of you that saw this before, you don't need to watch this. But for some of you, you've been struggling at looking at some of these limit problems and problems like, what is it, assignment 1, 2, or sorry, 3D is a struggle for some people. And then when we get to assignment 2, you're going to need this as well. So I figured I'd give you a quick refresher. And I'm not going to call this a definition because this is not a derivation or proof. I mean, this is actually showing why a definition is true using another methodology. But I'm going to show you why this expression to the right actually is E. And the reason why is that we don't know what this is, but I'm going to call it Y for a second. I'm going to say, let's just take the ln of both sides. So that's happening when I put my hand down, and we are going to just say, let's take the natural log of both sides. And then we can say, well, using our rules of the logarithms, we can do that. You look at that and you say, well, this first part here, this little x here is going to infinity. And ln of 1 plus 1 over x, well, that's going to be the ln of 1 plus 0. And the ln of 1 is effectively 0. So we have infinity times 0. And infinity times 0 was one of our indeterminate forms. Now, it's one of those indeterminate forms that we look at and say, great, indeterminate, we don't know what to do, we have to do something else. But we can't use some of the tools that we love, like our favorite tool, L'Hopital's rule. So we're going to do a little magic. Voila. We just created a quotient. And this quotient is now actually 0 over 0, which allows us to use L'Hopital's rule, right? The numerator is approaching 0. The denominator is approaching 0. L'Hopital's is a great candidate. So we're going to take the derivative of both sides. Sorry, I meant derivative of numerator and denominator. Okay. Don't forget our chain rule, the derivative of x to the negative 1. Now what's in the denominator? Oh, that's convenient, isn't it? Whoop. What happens when x goes to infinity? This approaches 1. Remember, this is the ln of y. So now we exponentiate both sides, and we get y equals e to the first, or e. So that's why this, by definition, let's go back to this initial thing that I wrote up way up here. That's why this beautiful expression is E. And that's a definition, folks. That is the definition of E. I didn't really prove it because I used things that you needed in order to, I used things like the derivative of ln, which needed this definition, actually. So we didn't really prove it, except for the fact that we showed, a reason why. And a couple of other cool things about this is that you will need this from time to time. A couple of cool things you can think about is that if I gave you a few different versions of this, I could give you this. And when you look at that and you say, well, those things are completely different, right? Well, yeah, right. One has x going to infinity, the other has x going to 0. The other has 1 over x where x's are and x's where 1 over x's are. But the reality is these are the same exact expression, folks. And the reason why they're the same exact expression is if you just did a u sub effectively and you subbed in u, like if you took the one in the green box and you just said, hey, let u equal 1 over x, then you'd get everything to the right with just u's instead, right? I mean, that's what we're doing here, right? Just, hey, this is what we would get. And the cool thing is that the letters really don't matter, right? The letters are just some kind of placeholder variable. So just like I put u there, I could put w there, I could put y there, or I could put x there, which is what I initially had. So it's just another version of the definition of E that you'll sometimes see. And then someone comes along and says, well, what about this? I'm going to use a different letter. just because I could end up with, I want to end up with x. So we'll just say, hey, let's do this problem here. About a nice big number, like 3. Well, what is that going to equal? Suddenly it got a little trickier, didn't it? Well, let's do our u sub, right? And again, I used y. I meant to use x. Let me go back in here and fix this. I want to get to y, so I'm going to do a u sub, though I'm going to use x. Okay, so we're going to say, let's let y, 3 over y, equal x. Okay. This was meant to go to infinity, folks. Sorry about that. Okay, so now we're going to have x going to 0, 1 plus x, and uh-oh. I think that's right. Looks right to me. And can I rework this a little bit? I think I can do this. Now, if you remember when we did limits, we talked about the fact that the limit of a product is the product of the limits. What does that mean? That means this is really the limit of something times something times something, right? Because that's what that cubed is really happening. So the reality is we can actually rework it like this. Because it's we can just think about each individual limit. We can do that. Look at that. See that E? That E is right up here, that definition I have. Let's put a red box around that second definition. I'm using that second definition. I'm just saying, wow, this expression right here equals E cubed. And this can be used for any number here. Any number that is here can be used for. And what it basically says is this following expression. And I'm going to use x again. I'm going to go back to x. If you have that expression here, folks, this is going to equal e to the a. It's going to be really important when you start seeing things like minus here and 1. So if that a is like a negative 1, you get e equals e to the negative 1. That might help you for a problem like look at a problem like number on assignment 1. Number, what did I say, 3? Yeah, 3D. You'll see the fact that the reason why that diverges is because what's happening is that the limit as x or sorry, as n approaches infinity of a sub n is 1 over e. So hopefully that clues you in. That's the reason why it diverges, because it doesn't equal 0. Anyway, cool little aside for E. You're going to need this kind of stuff. You need these kind of the green and red boxes you're going to need to know in general. It's a pre-calculus concept. Hopefully this refresher might help you do problems like 3D on assignment 1, and it might help you for what I'm going to show you eventually on assignment 2.